Okay, here we are. We're going to get started with lesson 112, relationships between triangles and circles, and this is part 2. And all of a sudden I forgot how to make this work. Your objectives are to define and identify points of intersection associated with triangles, and I guess I ought to get my pointer going out here. Use a compass and straight edge or technology to construct points of intersection in triangles and circumscribed and inscribed circles of triangles. Now, most of your problems in the problem set and when you go through the lesson are talking about constructing the triangles with the circles. And there's lots of instructions in the lesson, and there's instructions in the study guide on how to use GeoGebra. Some of these terms aren't real new because we talked about them in our last lesson, but centroid, circumcenter, circumscribed, incenter, inscribed circle, and median of a triangle. Now, what we talked about in the last lesson, some of the special centers were circumcenter and incenter, and this is just pictures of classified triangles. So let's take a look at the special centers that we got going here. First, we have an incenter, and that's the point where the angle bisectors meet. And here's a little note for you. Incenter is the center of an inscribed circle. Okay? Here's another little note I come up with. All incenters are inside the triangle. Incenters are always inside the triangle. Doesn't matter what kind you've got. So here's an acute incenter, here's the incenter of a right triangle, and here's the incenter of an obtuse triangle. And note that all the red lines that you see are all angle bisectors. Now with your circumcenters, it's a little bit different. Your circumcenter is the point where the perpendicular bisectors meet. And here's a little memory tool. It says circumcenter is the center of a circumscribed circle. Okay, so now when you have different types of triangles, your circumcenter is going to be at different spots. So when you have an obtuse triangle, your circumcenter is going to be outside the triangle. So if it's obtuse, it's outside. If you have a right triangle, your circumcenter will always be on the triangle. And then when you have an acute triangle, your circumcenter will always be inside. And now these dashed lines, every one of them represents a perpendicular bisector. Okay, so now we're going to be talking about a median. It's a straight line that goes through both a vertex and the midpoint of the opposite side, and it divides the triangle into two equal sides. Now notice this is the midpoint of the triangle, the side of the triangle, but it's not necessarily a bisector of the vertex, okay? But it is a midpoint of the side. Okay. Now, when you do all the midpoints for each side, you've done the midpoint for segment AB, the midpoint for segment BC, and we've done the midpoint for segment AC. When you draw from that midpoint to the opposite vertex for each one, you're going to create a centroid. Okay? So angle bisectors create an incenter. Perpendicular bisectors create a circumcenter, and medians create a centroid. So let's look at an example here. It says, which point is the centroid? Well, if the centroid, first you've got to think, okay, we're talking about medians. Medians going to the opposite vertex. So you're going to look up here at the information that they've given you about which angles are congruent. Okay, but for medians, you want to know what sections are congruent. Okay, so they said NS is congruent to SO. So that means point S right here is a median. And you look right here, S to L, that's a median from S to L. So, you know what? I like to mark stuff up. So let me go from, well, I gotta move this little palette out of my way. I'm gonna go from S to L. And then it tells me that LP is congruent to PO. I gotta find LP. Oh, LP to PO. Okay, so right here is going to be my median. And then let me see, I need, oh, they didn't do a median from this side. From the segment LN, they didn't create a median over there. But if I did create a median, and I'm just eyeballing this, and I went like that, it would still go through that point Y. So Y is going to be my centroid. So remember, your centroid is where the medians intersect. Okay, let's see if I can't make that a little larger there. Ooh, that's probably a little too large. There we go. Okay, the centroid is where the medians intersect. And so it looks like point Y is the guilty party. There we go. Okay, let's look at the next one. It says which point is the end center? Well, remember, your end center is where your angle bisectors meet up. Okay, and it tells us here that NLR is congruent to RLO. So N, you know, I like to draw NLR is congruent to RLO. So that right there tells me that LR is an angle bisector. Okay, so right now it's looking like point X is the guilty party here, but let's make sure. ONT, is congruent with TNL, and so I'm looking at these at this point Y. Now notice that they didn't do the angle bisector for O because you really only need 2 of them. You don't need all 3. But it looks like point X is going to be the end center in this one. That drawing really helps you figure out who's who. Okay, let's look at this one. Let me get this palette out of my way. Which point is the circumcenter? Remember, your circumcenter is all of your perpendicular bisectors. And right here, we know our perpendicular bisectors because perpendicular creates right angles. Perpendicular lines create right angles. So let's see. And it goes, there's perpendicular, and there's perpendicular. Oh, I was almost confusing myself. I needed to go straight. Since this is an obtuse triangle, that means that my circumcenter is going to be outside the triangle, which means point Z is going to be my circumcenter. Now if it was acute, remember, it would be on the inside, and if it was right, it would be on the triangle. But in this one, it's obtuse, and so it's point Z outside the triangle. Okay. Like I said, this was a short lesson because most of it is things that you need to be working on at home, doing the constructions by hand with your compass and straight edge, and or using GeoGebra. And all the instructions for doing both kinds of constructions are found in your lessons and in the study guide. So what we've learned in these lessons is the circumcenter, incenter, and centroid are all special centers of a triangle, and for any triangle, each of these points can be found using a compass and a straight edge. The construction for an incenter is based on the angle bisectors, and the construction for a circumcenter is based on the perpendicular bisectors. And remember, you're going to be asked questions from lesson 111 and 112 on the Unit 1 Part 2 test, so make sure you know them and you take notes well, because you're going to be able to use your notes on the test. What you should do after watching this video is reading through the lessons in the LMS and in the reference guide and complete these problems. And like I said, most of them are doing constructions. Be sure to contact me or attend TOGA if you have questions before completing the quiz 112, and then make note of any general questions you may have for when you attend CC on Thursday. And that'll be it. Thank you for listening.